Hello everyone, welcome to CX 10.10 TY session. I am Shubna, part of Switching TME team. So in this session, I'll walk through about RADSEC Cloudauth enhancements. The enhancements we brought in RADSEC feature to support Cloudauth. Let's start the session. So today's agenda will be seeing about the overview, details and caveats of this feature, how to do the configuration, best practices for this feature, troubleshooting RADSEC, and then demo of this feature. Let's begin our overview. So let me start with the overview of RADSEC. So RADSEC is a feature supported in our CX switches from 10.05 release onwards. So RADSEC is a radius over TLS. It is used for redirecting our regular radius traffic to remote radius servers connected over TLS. It is like a TLS tunnel formed between our access CX switches and then our radius server. ClearPass is one of the widely used RADSEC server. So in our RADSEC, we have following long-lived TLS tunnels. So why do we call them as long-lived TLS tunnels? So these tunnels will reside in the switches until there is any event like unconfiguring the radius server or rebooting the switch or the daemon restart, or if it is the tunnel is getting terminated by the other end, the RADSEC servers. So until then, these servers will reside in our switches. Hence, it is called it as long-lived tunnels. So we do have following long-lived tunnels. The first one is tracking tunnel. So responsibility of the tracking tunnel is to send the tracking request to identify whether the radius server is reachable or not. So once tracking tunnel identifies the radius server is unreachable, it will be marked as dead. So how the tracking tunnel identifies if the radius server is reachable or not? So it will be sending a radius tracking request with the username as radius tracking user. So once there is no response for that access request, the tunnel will be marked as unreachable and no more access requests will be sent to the particular dead radius server. So next is the port access tunnel. So port access tunnel is responsible for sending the .1x and MAC authentication, access and accounting request. Next is the ACTT tunnel, abbreviated as accounting daemon tunnel. This tunnel is responsible for sending the management accounting request. Management accounting request in the sense the accounting request for management users who tries to log in and access the management part of the switch using SSH, Telnet, console login and WebUI login. So we'll see what is the behavior of RADSEC before the 10.10 release. So we do have tracking tunnel for identifying the reachability of the RADSEC servers. So only in the tracking tunnel, the tracking request will be going on, and only that tunnel we can able to identify whether the RADSEC servers are reachable or not. So once the tracking tunnel has identified the RADSEC servers is unreachable, further access requests from the port access tunnel or from the accounting tunnel will not be created. Next is the port access tunnel. The port access tunnel, as I said earlier, it is responsible for sending .1x and MACauth access and accounting request. But there are chances like this tunnel can remain idle if there is no any new user trying to onboard, or if there is no accounting update for the users, this tunnel can remain idle. Once this port access tunnel remains idle, there can be chances like the RADSEC server will terminate the session of this port access tunnel. because of this idleness. So it varies from server to servers. In our clear pass, by default, the idle timeout is 15 minutes. So once the port access tunnel remains idle for 15 minutes, the ClearPass server will be terminating our port access tunnel. And from our switch side, we will try to again establish the port access tunnel after a waiting interval of 1 minute. So after 1 minute, again this port access tunnel will get established. But during the 1 minute, there will be not any port access tunnel in our switches. So during that time, if any new client tries to onboard, those clients' port access request will not be triggered and they may remain in unauthenticated state because of server unreachability. So this is one of the requirement why we do have to enhance our RADSEC feature for this cloud authentication. This RADSEC with port access and management access is supported in following platforms before 10.10 release: 6300, 6400, and 6200. So let's go ahead with the next slide. So we will now see like what are the enhancements added in 10.10 as part of this RADSEC Cloudauth enhancements. So as part of this RADSEC Cloudauth enhancements, we have following improvements to RADSEC feature. As I said previously, RADSEC was supported only in 6300, 6200, and the 6400 platforms prior to 10.10. Now when 10.10 release onwards, RADSEC for both port access and management access will be supported in 6000, 6100, and 4100i platforms. Next is the major other enhancements added in RADSEC. The first one is status server message. So we do have tracking requests for tracking the tracking tunnel daemon, but for port access tunnel daemon, there is no tracking request available. So if there is no traffic or no client onboarding happening in the port access tunnel, it may remain idle. So we do need a mechanism to track our port access tunnel and make sure the tunnel will not go idle. For that reason, we have supported status server messages and then TCP keep alive messages. So as part of this enhancement, we do have support for configuring interval for sending the status server message and statistics for displaying the status server request and status server response. And we have support for sending TCP keep alive for this RADSEC servers. So using this TCP keep alive, we could able to identify the socket status and we can able to determine the reachability of the RADSEC servers. So now we do have like status server messages, TCP keep alive, and tracking requests to track our RADSEC servers. And going forward, RADSEC will be supported in all 6xx platform, 4100i platform, and then 8360 platform for both port access and management access. Let's go over with the details of this feature. So let's see, why do we need status server and TCP keep alive as a tracking method apart from the tracking access request? The foremost reason is for the port access tunnel. So currently there is no tracking request sent in this port access tunnel. So once it remains idle because of inactivity, it can be closed by the RADSEC servers. So we have seen ClearPass has a default idle timeout of 15 minutes. It's a constant value. It cannot be changed. So if there is no user onboarding or accounting update, so the tunnel will be closed in 15 minutes. To make sure the tunnel never closes, And to make sure there are traffic residing in the tunnel, we can send either a status server message or we'll be using the TCP keepalive messages. Next is the tracking tunnel. So we already have a tracking request sent in tracking tunnel. So the tracking tunnel will not be going idle. But there are drawbacks with the tracking request. If you could see, this is the web UI of our ClearPass. And we can see only the web UI is full with radius tracking user details. So there will be frequent radius tracking requests sent from different switches. By default, the tracking interval is 5 minutes. So every 5 minutes, the switches will be sending the radius tracking user request. If it is an enterprise environment, the ClearPass web UI will be only choked with this tracking request. So to overcome this issue, we can have other tracking methods like status server and then TCP keepalive. So status server messages will be internally processed by the ClearPass. So it will not be displayed in the web UI of the ClearPass. And then the TCP keepalive messages. It works in the TCP layer and will be internally processed by ClearPass, and it will not be choking the performance of the ClearPass servers. And then the main reason is RADSEC over the cloud. So we do have support for cloud authentication in our central releases in future. So to have that support, we can have TCP keepalive as one of the tracking method to identify whether the RADSEC connected over the WAN is it reachable or not. So we'll see how status server and TCP keepalive works. So first is status server. Status server is an application level packet. Similar to a tracking access request, status server is a kind of access request message sent to the RADSEC servers. So this message is sent based on the configured interval. So by default, it is 300 seconds. So every 300 seconds, the status server message will be sent to the RADSEC servers. So these RADSEC servers will respond with the access accept message for the status server. So once we receive the access accept message for a status server message, we will assume that RADSEC servers are available. If there is no response for our status server messages, then RADSEC server will be marked unreachable. So next is TCP keepalive. So TCP keepalive is a TCP level packet that will be sent to identify whether the RADSEC servers are reachable or not. So the advantages of TCP keepalive, it is a TCP level packet and it will have a minimal load to our servers. So how a TCP keepalive works? We do have following parameters for this TCP keepalive. The first one is TCP keepalive idle. It is around 300 seconds. TCP keepalive interval 20 seconds. TCP keepalive packet count 5. So how a TCP keepalive works? So it will wait for TCP keepalive timer of 300 seconds. If the TCP packets are not received in the tunnel for 300 seconds, it will start sending the TCP keepalive packets. So it will be sending around 5 packets. So each packet will have an interval of 20 seconds. That is the TCP keepalive interval. And the number of packets is the TCP keep count. So these values are not configurable and they are based on the RFC, and these are the default constant values. So what happens if the TCP packets are not received and the tunnel is idle? So our TLS connection will wait for 300 seconds and then it will start sending the TCP keepalive packets every 20 seconds for 5 times. So after that, if there is still no response from the other end RADSEC servers, the TLS connection will be closed. So it will be taking around 300 seconds plus 20 into 500 seconds. So it will be after 400 seconds of no response from the RADSEC servers, our TLS connection will be closed. So this is how our status server and TCP keepalive works. So now let's see about the configuration, how we can configure this RADSEC Cloudauth enhancements. So the first configuration, radius server host, and then the IP or FQDN entry, TLS mentioning it is a RADSEC server, and then the tracking method. So the first CLI is for the tracking daemon. So we have already access request is enabled for sending the tracking request in the tracking tunnel. And we do have this new enhancement like keep alive and then status server message. So by default, we'll be using only the access request for the tracking tunnel. So based on the requirement, we can modify it to have TCP keep alive or status server. So next CLI is for port access tunnel. So here in the port access tunnel, we can mention what will be the tracking mechanism, whether it is keep alive or the status server. So the next CLI is about configuring the status server interval. So the status server interval by default, it is 300 seconds. So it can vary from 10 to 86400 seconds. So these are the new configurations that has been added as part of this enhancement. Let's see about the changes in show commands. We do have the existing show radius server command. So it will be giving a brief overview of what are the radius server configured in our switches. So in this show command, there has been new option to show the status server timer interval. So here it displays the default 300 seconds. If we modify the configuration, it will be updated in this show radius server command. The next detail command is show radius server detail. So this is also one of the pre-existing show command and it has been enhanced for this feature. So it will be displaying the status server timer interval. And then next it will be displaying the tracking method. So for each of the servers, it will be displaying what is the tracking method that will be used for the tracking tunnel and then the port access tunnel. For tracking tunnel, the tracking method is currently access request. That is the default tracking method. If we change it to keep alive or status server, it will be updated in the show command. Next is for the port access session. So the port access session for default, the tracking method is status server. If required, we can modify it to have TCP keep alive as well. So once we modify this show radius server data command will displaying the updated tracking method. So the next show command that has been enhanced is the show radius server statistics authentication. So this show command displays the statistics of the server, like how many access requests, challenges, accepts, and rejects has been transmitted from this switch to the server. So it has been enhanced to even include the status server messages. So we do have options to see the statistics for both the tunnels, like for the tracking tunnel and then for the port access tunnel. So currently we do not have enabled the tracking tunnel with status server messages, so it displays as 0. If we have enabled it for port access tunnel, if the status server messages are sent, here we'll be able to see the count of how many status server messages sent and how many responses we do have received from the RADSEC servers. So these are the improvements to the show commands as part of this feature. So now let's see the best practices for this feature. So we do have status server and TCP keepalive added as part of this feature. So not all the RADSEC servers currently support status server and TCP keepalives. So we need to make sure that RADSEC servers are enabled with status server and TCP keepalive. So only then, if there is a request from our switches like a status server or TCP keepalive packet sent, there will be a response from the RADSEC servers, and it will be able to us to identify whether the RADSEC servers are reachable or not. Till ClearPass version 6.10, we didn't have support for TCP keepalive. So we do have support for only status server messages in our ClearPass servers. By default, our ClearPass servers support status server messages. So when our switches send the status server messages, our ClearPass server will respond back. The TCP keepalive support is in pipeline for our ClearPass in version 6.11. So next is, which is preferable method? Is it status server or TCP keepalive? So status server is application level packets that will be sent for tracking the RADSEC servers. But TCP keepalive is a TCP level packet that will be sent to identify whether the TLS connection tunnel is up or not. So if the RADSEC servers is residing over the WAN, like we do have enhancement of cloud authentication coming in our central, where central will act as a cloud authentication server. So in such kind of deployments, where the RADSEC server existing over the WAN, it was advisable to have TCP keepalive. So the reason being is TCP keepalive is a TCP level packet. It will have less overhead to our RADSEC servers like our Cloudauth servers. And it may not choke the bandwidth of our central servers as well. So that's the reason TCP keepalive will be preferable for over the cloud applications more than the status server messages. So now let's see the troubleshooting part of this session. So how can we troubleshoot the status server message or TCP keepalive? So the first troubleshooting part is diag dump. So once you enable the diagnostic dump, we do have diag dump for the port access daemon. In the diag dump, port access basic will display the statistics of our radius servers. So here, as part of this output, there has been enhancement to add the status server statistics. So it will display the status server packets transmitted, like how many status server packets has been transmitted and how many status server packets has been received and how many is the timeouts. So it will help us to identify, was there a timeout that has caused the radius unreachability because of the status server messages has not been received. So that level of debugging will be helpful with this diag dump port access basic. So it will also display the TLS connection establishment status as well. TCP keepalive, we do not have any diagnostic dump because it is a TCP level packet. So let's start with the demo of this session. So today's demo, I have my 6300 switch. I'm using Radiator as a RADSEC server. This is one of the well-known RADSEC servers used in field. Next, our own ClearPass and RADSEC server. So here I opened the console of 6300 switch and then the Radiator console logs and ClearPass SSH session. So I'll be giving a demo of how a status server message works. For TCP keepalive, since the TCP level packet will not be able to identify in the consoles of the ClearPass or the Radiator server. So in this session, we'll see about only the status server messages. So this is a Radius server I have currently configured. It is Radiator RADSEC server. So I mentioned option as TLS. So currently it has been enabled with the tracking method as only the tracking access request. So if you see here, we will be able to see the tracking users. So there will be a radius tracking user sent based on the configured tracking interval. And once we get a response for that radius tracking user, it will be marked as reachable. So for this server 20.1.56 Radiator, so here it will be marked as reachable. And I am using the tracking method as access request. And for port access session, the tracking method is status server. That is the default tracking method for the port access session. So how we can identify what is a tunnel for which daemon? So this is a bash prompt command. So we need to go to the VRF where the RADSEC server exists. And we do have a netstat command with the option to display the port numbers. And I am gripping with the 2083, the default port used for TLS RADSEC connection. So here it will display the daemon specific tunnels created. And if you see the 20.1.56 RADSEC servers, we do have 3 long-lived tunnels. The one is for radius server tracking, the other is for port access daemon, and other is for the accounting daemon. And we could see the TCP ports that will be used for each of the daemons. For port access daemon, the TCP port is 37775. So in this daemon now, status server messages are sent periodically. And if you see the RADSEC server, we will be able to see those status server messages. So if you see, this is the IP address of the switch. It displays like receive status server message in the port 37775. This is the port command for the port access tunnel. So it will display the message as status server, and then the attributes, the switch identifier details, and then the message authenticator attributes. And then the RADSEC server will reply with the access accept message. So this message depends upon the RADSEC servers. It will be the brief message or a detailed message. So this Radiator server, it displays a detailed message of how many access requests or accounting requests are received in this tunnel. So once the switch receives the access accept for the status server message, it will be marking the RADSEC server as reachable. So based on the configured interval, this status server messages will be sent for the port access daemon tunnel. So it will make sure the port access daemon tunnel, it's not going idle, and it will remain even though there is no user onboarding or accounting request for .NET and Mac authentication in this port access daemon tunnel. So it will help us to make sure the tunnel never goes idle and it will remain always because of the status server messages. So this is what the debugging we can do it for the radiator RADSEC server. So next is I will show how we can able to see the status server messages in ClearPass. Unlike tracking requests where in the web UI of the ClearPass it will display the radius server tracking user, status server messages are internally processed by the ClearPass and it will not be displayed in the web UI of the ClearPass. We need to depend only on the SSH connection of the ClearPass. From the console, SSH console, we'll be able to see the status server messages. So I have used 20.1.100 as my ClearPass server. So for this server as well, there are two tunnels. One is the radius server tracking D tunnel. The other long-lived tunnel is the port access daemon tunnel. So here I have enabled the tracking method as status server for the port access tunnel and then even for the tracking tunnel. So I have mentioned like tracking is enabled and then the tracking method is status server. So here ClearPass IP address is 20.1.100. Even show radius server detail will be able to see the detail of this server where it would clearly explain like TLS connection is established and then the tracking method is status server and then the reachability status is reachable. And even for the port access session, the tracking method it will mention as status server. So this ClearPass is now tracked only using the status server messages. As I said, like in web UI, will not be able to see the status server internal messages. We need to rely only on the SSH of the ClearPass to view this status server messages. So the status server messages will be available in this directory in our ClearPass servers. It is in var, avenda, tips, log, RADSEC proxy. So this is the directory responsible for storing the RADSEC proxy logs. So here there will be the RADSEC proxy log stored. So we need to open the recent file in it. And in this file, we'll be able to see the status server messages received by the switch. So if you see here, so this is the IP address of our switch 20.1. So this is the IP address of the switch 20.1.249. So if you see the info like RADSEC and then the code 12 and ID 235. So this is a status server message with code 12. So as a response to the status server message, the ClearPass will be sending an access response. So it will mention like access accept as response to the status server message. And it will send it as a response like access accept. And it will be sending it over the TLS server. Like in the TLS connection, it will be sending this access accept message. So these highlighted logs will be saying when we receive a status server message from the switch and when it is getting responded by our ClearPass servers. So these are internal messages only for debugging purposes, but it will not be displayed in the web UI of the ClearPass. So we need to rely only on the statistics from the switch to debug whether it is because of the status server message response, is it our RADSEC servers are marked unreachable. So we do have this show radius server statistics authentication host to see the detail about particular host. So it will clearly display how many status server messages are sent for the port access session and how many status server messages are sent for the tracking session. So that's all the demo for this RADSEC Cloudauth Enhancements feature. Hope everyone understood about this feature. For any queries, you can get back to me. So thanks everyone for watching this session.